Alright, so this is the question, right? This is the question. Mhm. Uh, so the first question was we should find the limit. To find the limit, there's the function. So we find the limit as x approaching negative 3 from the left side, right? Okay, so this what happened. Again, I said something that when we are doing the limit of this, what happens is that most times we can find the limit sometimes. We can find the limit by just putting value inside. So here's the case approaching negative 3, right? From the negative side, from the left side, right? Of x. Let's try putting in. So let's just for reference, these are the thing we are approaching negative 3, right? From the left side. First of all, we are approaching on negative 3. When we look at function here, that's what's happening. The function is a piecewise function, meaning that depending on the value of the x you are putting in, the function is defined in a different way. So here saying that whenever x is less than or equal to 0, we use this part of function, right? So negative 3 is exactly less than 0. So we are in this. So let's see. X squared minus 9 all on x 9 to bracket x plus 3. Then again, sometimes you can find the middle just putting the value in directly. Let's see if that will happen. So we try doing that. And then at times when you don't get the limit, that you must do something to the function to get the limit. Because, but at times you just put a value and then you get a limit straight for it. Okay. So in our first particular case, we end up doing something that is undefined, right? So let's see. We have x bracket x squared minus 9, hold on, 9 bracket x plus 3. If we try putting we are checking when x is negative, right? So like we are just trying to see if we put a value directly we get an answer. So in indeterminate form, right? So what happens in this particular one is that when putting negative 3, and again when putting negatives, you must be very careful. Like for this negative 3 is actually squared minus 9 here. So you can use the different bracket to show the difference. So this is what happens. Get to it. So this is what we end up getting. This is 9 minus 9 is 0. So we end up getting 0, which is an indeterminate form. Right? As it's written here, indeterminate form. So in case like this, you have to find a way to make the function not 0 and 0, which is an indeterminate form. So that's what we do. We write it out and expand and do whatever we can. So let's see. X squared minus 9, right? And then we have 9 to x plus 3. So this is what we can expand the top side. So we're not getting the 6 minus 3 bracket x plus 3. It's from this side that we get all of this, right? Yes. So the down is base and mid. The cancel one out. So when I've seen this, right, which is x bracket x plus 3 or 9, right? Fine. And now can put in the values at 6 negative 3. So right, negative 3 bracket negative 3 minus 3 and what? 9, right? Negative 3 negative 6 9. And now get 2 for this, right? So this is the actual limit. Right? So that's the limit we get on this side. Even if the question will happen to be approaching from both sides, it will be the same thing because the question is still saying approaching negative 3. And then from the right side, we'll still be in the what do you call it? We'll still the function will still be defined by this one. Right? Because we're saying that anything that's less than or equal to 0 here, we use the side, right? So we still use one, we still get the same answer, but we'll have to just put in the negative thing. It's just the same thing, right? Let's see. What's the second question? Yeah, so the second question is found. We are then approaching the right side, the same thing, because of how this particular function is. Third one saying that what do we the function is f of x equal to square root of a, right? We should find the limit. Sorry, the limit is actually f of x. The limit of the particular function is still negative. Sorry, it's still root of 3. Why? Doesn't mean that that f of x or function function is actually a constant function, right? Constant function is function that irrespective of the value of the x that you or the input that you put in the function, the value is still the same. So you see, if we do a function of this sort, meaning you have to substitute some x value in like this one. You have to substitute some x value in it to see what happens, right? But for this particular one, there is no x in it, right? It's not dependent. Function is not dependent on x, right? So whatever value of x has that you have to find limit to still remains the same. It doesn't affect the next sorry the return here. Okay. It doesn't affect the return. So that's why the limit of this function here. Even if the approaching whichever number is, even if you're approaching 50, even if the limit is approaching let's see, whatever, positive or negative infinity, the limit is approaching let's say positive 2 from left side, from right side, it's not the same. Because the function is root of 3. There's no x or not in the function, right? The function is not dependent on the x. That's why the limit is still 3. The limit is still 3. Sorry, root 3 rather. This is a constant function. Still root 3. Whichever way that it is oriented, it's still root 3. That's how constant function work. Because they're not dependent on the x. Whatever the value of x that you put, so you want the value to whatever value of x that you want the function to approach, it's all root 3. It doesn't change it. So yeah, so that's it. Alright.